Passage 3. This passage is about fluorescence in animals. Animals emitting color. Fluorescence in animals. Interesting. Let's find out what is the interesting fact revealed in the passage. Quick summary before we look at the questions. At first, it seemed to be another caprice of two already unusually animals. Flying squirrels and platypuses were found to be fluorescent, absorbing invisible ultraviolet light and re-emitting it in shocking pink or bright cyan. So we thought this is something strange about two strange animals, the flying squirrel and the platypus. They were found to be fluorescent. But they are far from alone. But later we found out that they are not the only animals which are fluorescent. Lions, polar bears, scaly-tailed possums and American pikas are also fluorescent. These also give off light. So does every mammal species a group of scientists could get their hands on. It's not just these two animals. Every mammal species tested by scientists seems to flourish or be fluorescent under conditions. While this large survey of museum specimens doesn't reveal any broad evolutionary benefit, it overturns the view of mammal fluorescence as an occasional and mysterious quirk. Instead, it appears this trait is basically the default. So what's the author is saying? There doesn't seem to be any great evolutionary benefit in the mammals being fluorescent, but it overturns our view that only certain animals can emit light. That it seems to be the default setting. It seems to be like most of them do, maybe a few don't. Wondering if this was universal across mammals, scientists decided to expand their inquiry. Taking advantage of the museum, so they have this museum. So they took advantage of the museum's collections to include as many species as possible on the mammal family tree. They conducted experiments on a wide range of mammals. One by one, the mammals went under spectrophotometer. A koala's light belly and ears fluoresced greenish. A ghost bat's bare wings, ears and nose leaf gave off a pale yellow. Even a house cat's white fur emitted a faint gleam. So these are the results of the experiment. Any animal they got seemed to show something. A koala, a ghost bat, even a cat. In the end, specimens from all 125 species, they tested 125 species, and specimens from all 125 species they tested showed some degree of fluorescence. Most often, it came from structures made of unpigmented keratin, such as white fur, the bare skin of pouches and paw pads, or accoutrements like quills, claws, and whiskers. So it seems to be from unpigmented keratin. And these kind of structures, fur, bare skin, paw pads, quills, claws, whiskers, these were fluorescent. In some cases, the pigmented fur also fluoresced. So not just unpigmented keratin, pigmented fur also fluoresced, suggesting other materials can be evolved. Previously seen in spring hares whose fluorescence doesn't match their color pattern has been traced to pigments called porphyrins. So even pigmented part structures the body fluoresced. As in the past, the discovery of fluorescent living things brings up a tricky question. Can mammals even detect these glows in nature? So the first question, can mammals even detect these fluorescent glows in nature? For the most part, the photographs of splotchy spring hares and radiant polar bears in articles are taken in artificial conditions that maximize their effect. They don't reflect appearances in the real world. So we have pictures of polar bears fluorescing, but he says these have been taken in artificial conditions. They do not reflect appearances in the real world, where the power of the rest of the light spectrum drowns out these hidden colors. In addition, prey species which are prey rather than predators tend to have it on the belly, but carnivores tend to have it on their back, suggesting a potential brightening effect under moonlight that could help predators recognize their own species. In the night, you're going on a hunt, so if it's on the back, a predator can recognize another predator, and rather than going after it, would go for the hunt. Other experts, like Mrs. Reinhold, question whether moonlight would provide enough UV to make this happen. So there is one theory. Predators have it on their back, preys have it on their belly, so maybe the predators having fluorescence on the back helps them detect other predators. But then others are questioning, experts are questioning, darkness, moonlight, does it provide enough light even for the fluorescence to happen? It's difficult to imagine any utility for some animals newly added to the glow chart. First, we thought very few animals had it. Now, almost every animal has been added to the glow chart. The animals which are newly added to the glow chart, the author says that we can't see any utility of this fluorescence in such animals, such as the southern marsupial mole. The example being the southern marsupial mole, which is blind and spends its entire life underground. So, where's the question of light? Where's the question of fluorescence? But it also has fluorescence. A professor of behavioral ecology said it should be put to rest the idea that fluorescence in animals is necessarily a signal. So, such examples, according to Ines Cuthill, a professor of behavioral ecology, says such examples should quieten all those theorists who say, oh, it must be a signal. Cannot be. It must be having some other function, or maybe it has no utility at all. But we may not be at the rainbow's end. We may not be we have not reached the solution yet. Given the study's findings on potential confounding effect of preservation, examining the live animals of these species might be mind-blowing. I hope this study will inspire others to go forth into the wilds with a UV flashlight. We still need a long way to go to understand the utility or function of these fluorescence. Which one of the following statements contradicts the arguments of the passage? So, which one goes in line? We reject those. Which one contradicts? That's the one we want. Fluorescence is universal among mammals, almost universal. Fluorescence among mammals have some utility value that has been challenged. People feel, put that idea to rest. Maybe they have none. They don't know yet. So you can't say for sure that this is correct. He says it so far there seems to be no utility value, especially when you take the example of the mole, which lives underground and is blind. So neither can it see fluorescence in others, nor, because it lives underground, others can't see it. Different mammals fluoresce in different parts of the anatomy. Predators on their back, preys on their bellies. Fluorescence involves absorbing and emitting it. A, C, and D can be inferred. B cannot. Therefore, B contradicts the passage. Right? All right. Next one. All of the following claims can be inferred from the passage except. Which one can't be inferred? Fluorescence need not occur only from unpigmented keratin. We know that. Unpigmented mostly, but pigmented also they have found in some cases. Mammals fluoresce mainly for signaling purposes. In the passage he says, put to rest that it's a signal of some sort. The example of the mole, which is blind, lives underground, but still. So there's no evidence that this has been used for signaling. That's only a theory. So that B cannot be inferred. That's our answer. But let's look at C and D. Carnivores probably forest to be able to recognize their own species. Probably. One of the theories says maybe when they are in the darkness, they can identify other predator species. Prey species tend to fluoresce on their bellies or stomachs. So A, C, and D has been given, can be inferred. B is our answer. But we may not be at the rainbow's end. What can you interpret from this statement? Reaching the end of the rainbow, the pot of gold at the end of the rainbow is getting your answer, getting your reward. That's the figurative expression. And in the context of the passage, what does he mean? The real reason As to why mammals fluoresce is still to be known. We still don't know. Right? Some said maybe this, that. So let's go with UV torchlights to find and come to some sort of answer. Therefore, A is the reason. He says we have not yet come to the end of the rainbow. We still not figured out. We are not at the end of the road yet. What is the primary purpose of the author? Why has he written the passage? Reveal the unknown fact that all mammals fluoresce, ascertain causes for mammal fluorescence, describe the process of fluorescence among mammals, give reasons as to why different mammals fluoresce in different parts of the anatomy. Probably this is the reason. That's a minor part of the passage. He does not describe the process of fluorescence except saying absorb UV lights and remit. Ascertain causes he has not told us, but he says, look, earlier we thought only 2, but scientists made this experiment with 125 species and found that all of them do. Therefore, the correct answer is option